Diving into homework 3, starting with problem 1, when talking about heat conduction through a wall. Steady heat conduction will cause a constant energy content because the energy going in is equal to the energy going out, whereas that is not true for transient because those values are not equal. Moving on, a soda can wrapped in a blanket will have an insulator on it, so the heat will have a harder time piercing through that blanket and will require more energy to heat up to the temperature that it needs, so the can on the table will warm up faster. Through this problem, we're really just looking at truly finding the R total, so we can use it in this equation down here. So we need to find R convection 1, R glass, and R convection 2. Use that simply with the equations that fit the resistance that we need to find, adding them up and then plugging them into the Q equation. And then once we have the Q equation, we can rearrange the Q equation for just the first state and then find T1. Looking at this more complex equation with 5 circuits, our total is just going to be the addition of all of them. R1 is going to be a simple equation. R2 is going to be equal to R5. As well as for 3 and 4, you have to calculate it for the stud and the fiberglass using the following equations. R6 is just another simple equation. And then from there, you need to solve for R3, 4 in this equation. And since they are in parallel, you put them inverse and then are able to get that value so you can solve for your R total. Now to find the Q dot, you just use the Q dot equation and find the Q dot of the change, and then use the change over the area to find the total Q dot. Now moving on to the problem with the pipe, same simple thing. Our total is going to be R1 plus R2 plus R3, and you're going to go through the equations. R2 is going to look like this because it's inside of the pipe. And then H combined has to be accounted for here because you don't only have convection, you also have radiation loss. So you account for that over here. And then once you have your R total, you simply just use the Q dot equation again to find your Q dot. And then you can use Q dot equals MCAT equation, rearrange a little bit to get a mass flow. And then to find the volume flow, use this equation. For 1455C, these are the two respective equations for heat conduction and mass diffusion, and the heat conduction rate are these two variables, thermal conductivity is these two variables, and temperature are these two variables. 1456 is going to be true, false, and then the last problem, you're simply using these following equations to find your mole, your flow in terms of moles, and then you just need to convert that to grams and then following the same equations here.